In 2019, we saw this, a blurry orange donut that broke the internet. 7 years later, we're now seeing black holes in ways that would have seemed impossible. But what happened in between is where things get really strange. And by the end of this video, you'll see something that even astronomers didn't expect. April 10th, 2019, the world stopped scrolling for a moment, because for the first time in human history, we weren't just imagining what a black hole looked like, we were seeing one. This fuzzy orange ring, this is M87 star, a supermassive black hole 55 million light-years away. It's 6.5 billion times the mass of our sun. But here's what blew my mind when I first learned this. To capture this image, scientists had to turn the entire Earth into one giant telescope. 8 observatories, 4 continents, all synchronized to the atomic second. And get this, the data was so massive, they had to physically fly hard drives between continents, 1/2 ton of hard drives. This black hole's shadow alone could swallow our entire solar system. The ring you're seeing, that's superheated gas moving at nearly the speed of light, being torn apart just before it crosses the point of no return. That 2019 image, it took 2 years to process, not because the computers were slow, but because they had to teach artificial intelligence what a black hole should look like first. Think about that. We'd never seen one before, so how do you tell a computer what to look for? Dr. Katie Bauman and her team had to create algorithms that could distinguish between actual black hole signals and literally everything else in the universe creating noise. But even after all that work, look at this image closely. See how blurry it is? Each pixel here represents an area bigger than our solar system. That's like trying to read a text message from across a football field. Scientists called this image revolutionary, but also frustrating, because they knew there was so much more to see. And that's when things started moving fast. Between 2019 and 2024, 3 things happened that changed everything. First, the network grew. By 2022, the Event Horizon Telescope added 3 new observatories, more eyes on the sky, more data points. Then, in May 2022, they dropped this, our own black hole, Sagittarius A star, sitting right at the center of the Milky Way, 27,000 light-years from where you're sitting right now. But notice something weird? This image is also blurry, even though this black hole is 2,000 times closer than M87 star. Why? Because Sagittarius A star is like a hummingbird compared to M87 star's eagle. The gas around it orbits completely in just minutes. M87 star takes days. So capturing SGR-A star was like photographing a toddler who won't sit still. But here's where the real breakthrough happened. Second, AI got scary good. Between 2022 and 2025, machine learning algorithms improved by orders of magnitude. Scientists could now fill in the gaps between those pixels with terrifying accuracy. Third, space telescopes joined the party. In late 2024, the Event Horizon Explorer satellite launched. For the first time, we had telescopes in orbit working with ground stations. No atmosphere to blur the view, no weather delays, no Earth blocking half the data. And that's when we started seeing this. Welcome to 2026. This is M87 star again, the same black hole from 2019. But look at the difference. We've gone from orange donut to seeing structure, actual features. That bright spot at the bottom, scientists think that's a hot spot in the accretion disk, a magnetic flare larger than our entire galaxy's spiral arm. See these wisps and tendrils? Those are magnetic field lines being twisted by the black hole's rotation. Each one of these streams contains more energy than 1 trillion suns. And this is the part that has scientists losing sleep. That faint streak shooting out from the top, that's the base of the relativistic jet. This jet extends for 5,000 light-years into space, moving at 99.9% the speed of light. And we can now see where it starts, the exact point where it's being launched near the event horizon. But here's the discovery that changes everything. We can now measure the black hole's spin, and M87 star is rotating at nearly the maximum speed possible, 93% the speed of light at its equator. This rotation is so extreme, it's literally dragging space-time around like a spoon stirring honey. And we're not stopping with just 2 black holes anymore. As of February 2026, the network has captured detailed images of 7 supermassive black holes, each one different, each one revealing new physics. Some spin fast, some slow. Some have thick disks, others thin. Some shoot jets, others don't. And we're finally starting to understand why. So what changed between 2019 and 2026? We went from 8 telescopes to 14, from purely ground-based to Earth and space networks, from classical computing to AI-enhanced imaging, from 2-year processing times to near real-time analysis. But more importantly, we're now testing Einstein's equations in the most extreme laboratory in the universe. And so far, Einstein's still winning. Even a century later, his math predicted exactly what we're now seeing. But here's what keeps me up at night in the best way possible. By 2030, there are plans for a constellation of space telescopes specifically designed for black hole imaging. Not just 14 observation points, but hundreds. The images we'll get, we'll be able to see individual orbits of gas around the event horizon. We'll watch material fall in real time. We might even detect the subtle wobbles that could prove Hawking radiation exists. And here's the wildest part. We'll be able to see black holes not just at the centers of galaxies, but potentially anywhere in the universe. Stellar mass black holes, intermediate mass black holes, maybe even primordial black holes from the Big Bang. 7 years ago, we saw our first blurry donut. Today, we're watching space-time itself being torn apart in 4K. What we'll see in 7 more years? Even the scientists won't predict that one. If this blew your mind even half as much as it blew mine, smash that like button. And here's a question for the comments. If you could ask a black hole one question, what would it be? Next week, we're diving into what happens if you actually fell into one of these things. Spoiler alert, it's weirder than you think. Subscribe so you don't miss it. I'll see you in the next video.